Good noon all. So we have to continue with the last lecture where we have to discuss structure of heme group, which is a metalloporphyrin. Metalloporphyrin means a coordination complex of metal and porphyrin acting as ligand in this case. Porphyrin we had discussed in the last class. Today we have to discuss the complete metalloporphyrin for the heme group. Heme group, which is forming the basic unit in hemoglobin and myoglobin, which is required for the respiration process in living organisms. Hemoglobin, the function of hemoglobin and myoglobin, you all know about that both of these are required for transportation and storage of oxygen in human body or in living organisms. So we have to start with the structure of myoglobin and hemoglobin, for which the basic unit that we have to discuss first, the structural unit, this is the heme group. Heme group, the metalloporphyrin, made up of the porphyrin, the macrocyclic ligand, having 4 pyrrole rings in the structure. A macrocyclic giant ring structure is this one, which is tetradentate in nature, and when joined to the metal iron in 2+ oxidation state, it leads to formation of the heme group. So let us see how easily you can draw the structure. For this you have to draw the periphery of this structure first. So this is the periphery, roughly the periphery of this structure. Next you have to complete the 4 pyrrole groups in the ring, which are occupying 4 corners of this heme group. So these are the 4 pyrrole groups which are present in the structure. Now as long as this is a porphyrin group, this will be having the presence of 2 hydrogens like this in the structure, or 2 protons, which in deprotonated form means when this is removing out 2 protons, this will be changing to its dianionic form, where in the dianionic form this will be coordinating to metal in 2+ state, metal ion in 2+ state, for formation of the metal porphyrin complex. So as we are talking about the heme group, the metal in this case in 2+ oxidation state, this will be iron. Fe in 2+ state, when coordinated to this tetradentate ligand, will be leading to formation of the heme group. But exactly not completely, this structure is not complete. To complete with the structure, we have to provide first conjugation in this structure, provide rigidity. Conjugation in the structure, this will be providing the delocalized pi electron character inside the ring, which will be providing rigidity to the structure. So let us see how we can provide conjugation in the structure. For this you have to show the presence of alternate double bonds, alternate single and double bonds in the structure. So let us see how you can draw. So these two, next this one, then next to provide conjugation it has to be drawn here, then one leaving, next and this one. So you can see that we have provided conjugation, the delocalized pi character in the ring structure, and hence stability to this ring structure. Still the structure is not complete. We have to complete the structure by providing the substituents on the periphery, or the side groups on the periphery of this metalloporphyrin or iron porphyrin complex. So to complete the structure, we have to complete the periphery by drawing the carboxylic groups like this, and the second with a negative charge. Next there will be presence of the methyl groups on the periphery also. Next the other methyl groups, and the last functional groups taken as R1 and R2. The presence of R1 and R2 will be differentiating in different types of heme groups, which are classified as heme A, heme B and heme C. Right? For hemoglobin and myoglobin, you will be requiring heme in B class. So the myoglobin and hemoglobin, both of these are coming under the second category, the heme B, where R1 and R2, both of these are the vinylic groups, right? So if R1 and R2, these are the vinylic group, these will be giving you heme B, which is the class for myoglobin and hemoglobin, right? So this is about the structure of hemoglobin. This is about the structure of the basic unit heme for hemoglobin and myoglobin. Now this structure, this is having the presence of central metal iron surrounded by the macrocyclic ring structure, which is the porphyrin ligand, which is tetradentate in nature, because here you are having 4 linking sites provided by 4 nitrogens present in the macrocyclic ring structure of porphyrin ligand. As such, the structure is square planar with 2 of the axial positions vacant. Right, so exactly now up to this point we are having a square planar arrangement of the metalloporphyrin or the heme group whose 2 axial positions are still vacant. These 2 axial positions, these can be occupied to complete the structure of hemoglobin and myoglobin. These can be occupied by the presence of the side long chain, the side long polypeptide chain, which is the globin part, polypeptide chain, which is the globin part. This is the polypeptide chain which is occupying the 5th position, one of the axial positions with respect to iron center, to give you the structural unit for myoglobin first. So to complete the structure, this 5th position, this is occupied by the polypeptide chain and is linked to iron by the nitrogen atom of histidine residue, whose imidazole group is providing nitrogen to join with the iron center. Means iron is joined to the globin part or the long polypeptide chain, which is made up of a number of amino acids, and the amino acid which is linking to the iron center, this is the histidine residue whose side chain made up of imidazole group, or you can say the imidazole of histidine residue. This will be joining to the iron center to occupy 5th position of this heme group, right? So this can be shown as and O, right? So this is the histidine residue whose imidazole group, this complete is the histidine residue of the polypeptide chain whose imidazole group is providing nitrogen to join with the iron center of the heme group completely to give the structure of myoglobin. To give the structure of myoglobin, right? So you will be wanting to know about the separate structure of this histidine residue. So histidine, it can be drawn as this is the histidine residue which is joined to the iron center through its imidazole side chain. So what is this imidazole? The imidazole, it can be drawn as this one. So this is the imidazole group whose nitrogen, this is linking to the iron center to occupy 5th position of the structure of the heme group, and hence giving you myoglobin first, right? Myoglobin, this is one of the structural unit, which is required for the process of respiration in human body, right? So this is how you can prepare the structure of heme group. Next, when joined at the 5th position to the histidine residue of the long polypeptide chain, the side chain, the globin part, the polypeptide chain joined through imidazole group of the histidine residue, this will be giving you the square pyramidal arrangement square pyramidal arrangement of myoglobin, right? Still you are having the sixth position unoccupied, right? Therefore this is square pyramidal in nature because of the occupancy of 5 positions with respect to the iron center, because 4 of the positions these are occupied by nitrogens of the porphyrin ligand, giving it a square planar arrangement. 5th position occupied by the globin chain or globin part or the polypeptide chain by the histidine residue. 6th position is still vacant, right? Now as long as this is not bound to oxygen, the 6th position when present in human body, as we all know that maximum of the body part, human body, this is made up of water, means 70% of our body this is having water in it. So this 6th position, this is generally occupied by water molecules, right? So if we are covering the 6th position by water molecules, this complete is giving you the octahedral structure of myoglobin, right? As long as this is not bound to oxygen, जब तक ये ऑक्सीजन से बाउंड नहीं है, myoglobin not bound to oxygen, this octahedral structure, this is named as deoxymyoglobin, right? सो दिस आई वॉन्ट टू टेल, बाकी आप लोगों ने नोट्स में से पढ़ना है, मेरे ख्याल से यहाँ से आप लोगों को काफ़ी इन्फॉर्मेशन मिलेगी दैट हाउ इजीली यू कैन ड्रॉ द स्ट्रक्चर. इसको ध्यान से आप लोगों ने देखना है. ध्यान में क्या रखना है कि हीम ग्रुप में कंजुगेशन बहुत ज़रूरी है. कंजुगेशन आप लोगों को ध्यान से ड्रॉ करनी है. हीम ग्रुप के सेंटर में आयरन surrounded by the conjugated porphyrin ring, and at the periphery you have to write all the functional groups properly, right? This will be your heme group when joined at the 5th position by histidine residue by the imidazole group. This will be giving you the square pyramidal arrangement of myoglobin, and the complete octahedral structure will be formed when the 6th position is occupied by water molecules. This will be the form for deoxymyoglobin when this is not bound to oxygen, right? So this is the structure of heme group. First we have discussed about heme group converted into myoglobin, the octahedral structure of myoglobin, the deoxymyoglobin we have discussed, right? Now from this we can make a difference between hemoglobin and myoglobin. What is the major difference? That myoglobin, this is taken as the monomeric form of hemoglobin. Myoglobin, this is the monomeric form of hemoglobin, where hemoglobin, this is tetrameric in nature. Hemoglobin is tetrameric in nature, means the structure of myoglobin and hemoglobin both will remain the same. The basic units will remain the same, means in both the structure myoglobin and hemoglobin you will be having the basic heme group joined to the polypeptide globin part by the imidazole group of histidine side chain of the histidine residue, imidazole group of histidine residue, right? But what is the difference between myoglobin and hemoglobin? That myoglobin, this is monomeric, whereas hemoglobin, this is tetrameric in nature, right? Means in the structure myoglobin you will be having only one heme group, whereas in hemoglobin you will be having 4 heme groups in the structure. So up to this point I think I have covered about the structure. You will be able to compare with the notes and have enough idea about the structure of myoglobin and hemoglobin. Next we will discuss in the next class about the oxygen binding curve, about the role of hemoglobin and myoglobin, and we will be starting from this point again in the next class. Okay, thank you, take care all.